The second lecture video on work, power, and energy is going to cover the topic of work when the force isn't entirely applied in the direction of motion. By definition, like we mentioned in the previous video, work is the product of the force in the direction of motion and the displacement. Many times, however, the force isn't always applied strictly in the direction of motion. Sometimes it might be applied at an angle. If the force is at an angle, but the motion is strictly in x, the x component of force, or F sub x, is equal to the force multiplied by the cosine of the angle theta. We can substitute this into our original equation for work to see that when the force is applied at an angle, work is equal to the force times the displacement times the cosine of the angle. Using the cosine of the angle gives us only the part of the force that is in the direction of motion, which we are assuming is x in these types of problems. Let's look at one example where the force is being applied at an angle. A person pulls an object along level ground a distance of 22.0 meters by exerting a constant force of 235 newtons at an angle of 25.0 degrees with the ground. How much work does she do? First, we will write down all the information we were given in the problem statement. We know that the force the person is pulling with is 235 newtons. The distance the object moves is 22.0 meters. The angle they are applying this force is 25.0 degrees. We are trying to find the amount of work, W, that she does. The basic equation to calculate work when the force is being applied at an angle is work equals force times displacement S times the cosine of the angle the force is being applied. Since this equation is already written to solve for work, this will also be our working equation. The last thing we need to do is substitute our data into the problem. Work equals 235 newtons times 22.0 meters times the cosine of 25.0 degrees. This gives us work of 4,690 Newton meters, or 4,690 joules. This concludes our discussion on work.